Quickly. So, today your class is till 7:30. Today the students sitting here offline in the classroom. Your class is till 7:30, and from 7:30 to 8, we will be having from 7:30 to 8, half an hour. We will be having our online doubt session. Okay. 7:30 to 8 p.m. we will be having our online doubt session. So everyone sitting at home, remember this. I'll be clearing your doubts from 7:30 to 8 o'clock. Okay. And so, Aditya, I want your lips not to move at all for this 1.5 hours. Sit down. You will not say anything, you will not complain anything. Okay? Okay. So last day I think I gave a homework.
Yes, sir.
Everyone will maintain pin drop silence. Last day I gave a homework.
Yes, sir.
What was the homework? From LCM and HCF self-practice, isn't it? Last year we completed chapter 5, LCM and HCF. And I told you, I gave you a homework from chapter 5, LCM and HCF. Self-practice, all the questions, 13 questions. Did you try it? Did everyone try it? Where is it? Where is it? Where is the homework? Where is the homework in your copy? Huh? You didn't do it copy. What do you do? In your head? You just mark. The answers are already given. The answers are already given. Marking you can do from this only. The answers are already given. You have to do it in a copy, isn't it? It's 7 LCM. Where is the copy? Where is the proof? Where did you do it? You did not bring the copy. No, sir, I left it at home. Doubts from? Chapter 4. We'll look at the doubts later, okay? Huh? We'll look at the doubts later from 7 o'clock. Where's the homework? Where's the homework? Where's the copy? Where did you do it? You studied Lalit Castle? What is this? Lalit Castle? No, little. Where's the homework? Huh? This anyone can mark from here. Where's the homework in copy? Why didn't you write it? Where did you do it? How did you find the answers? You did everything. You could do everything. All the questions. How did you tick mark all of them? You could do all the questions. Huh? Aditya, you could do all the questions. And why do you tick mark all of them? The answers are already given down, isn't it? The answers are already given. The answer keys are already given in the same page. Huh? And these boys are showing this and I've marked the answer with the pen. That anyone who doesn't know anything about mathematics can do that. Where is the proof that you did the LCM and HCF, the solution? Where is it in your copy? Show your copy. Do you have it? No. Did it? Where is the homework? You did not do it. Very good. Where is your homework? Put in it? Did not do it. Huh? Did not do it. Vajinath, where is your homework? Huh? None of you did your homework, right? None of you did your homework. None of you did your homework. Did you get your test papers?
No, sir.
None of you?
No, sir.
Did your parents take your test papers?
No, sir.
They don't ask you, how was your test? How much did you get? Huh?
Yes, sir.
Where is your homework, Roshni? Huh? You didn't do. You went somewhere. Where is your homework, Emma? You also didn't do. Some excuse, right? Yesterday in the morning, I gave the homework. Nobody tried even one question. How busy are you all? How busy are you all? Where is the homework? What's up? Very busy, isn't it? Huh? Where is Narendra Modi? Let me see. Where is Mr. Modi? Modi ji? Where are you? Huh? Where is the president? Who is the president of India? Draupadi ma'am? Are you here? Huh? Who is the chief minister of the state? Sir, where are you? Huh? Maybe you are very busy. That's why you couldn't do the homework, right? How busy are you? Yesterday after going home, it was Sunday, at night, you could have sat down with Elsa and itself. At least 4 or 5 questions you could have tried, isn't it? Very good. Yes, why did you raise your hand? You can unmute. Yes, tell me. Mistakenly? Okay. Everyone sitting at home, your doubt session will be from 7:30 to 8. I've written on the board. Remember this. Everyone sitting at home, your doubt session will be from 7:30 to 8. Okay? From 7 to 7:30, we'll have offline students doubt session. From 7:30 to 8, we'll have online student doubt session. Now to 7 o'clock, we'll do the next chapter. Yes, Amulya, why did you raise your hand? You can unmute. You also mistakenly. Very good. What about you? Why did you raise your hand? What is your name? Yeah, why did you raise your hand, Anvi? You don't have textbook. Are you new? You didn't get the textbook from the institute? Huh? You didn't get? Okay, you talk to the institute. You talk to ma'am about this. Okay. You talk to our timetable ma'am about this, about the textbook. Okay. They'll arrange it for you. Yeah. What is your name? Danvi, na? What is your name? Danvi. Okay. You call them today. Okay, and ask them for the textbook. Yes, Amulya. Why did you raise your hand again? Yes, I have started arithmetic, isn't it? We have done 5 chapters already. Yes, I will try to do as many chapters as I can. I will go through all the chapters as quickly as I can. Okay, and we cannot do each and every question in the class, can we? I will show you how to do a few questions, 2 or 3 questions, in the class, and your job is to sit at home and practice those questions. Try those questions yourself. Your job is to try all the questions by yourself, and then if you have any doubts, ask it in the doubt session, isn't it? Yes. Yes, you can unmute. Yeah, good evening, tell me. Yeah, tell me, what is your doubt? Why did you raise your hand? New student, okay. What is your name? Sorry? Manvita. Okay, so Today, Manvita, did you get your book, your Navodaya book? Yeah, today we are going to start chapter number 6, okay? We are going to start chapter number 6, decimals. We have already completed up to chapter number 5, LCM and HCF. Okay? You can go through those chapters yourself. And if you find any doubts, you can ask your doubts in our doubt sessions. Okay? From tomorrow, you can ask your doubts in the doubt session. Okay. Yes, Ragana, why do you raise your hand? Sorry? Have you done the homework, Ragana? Okay. Do you have any doubt? Any question you couldn't do? You could do all of them? And did they match the answer keys given in the bottom of the page? Okay, well and good. I am giving the homework mostly. See, I cannot check each and every homework of online students. I can check the homework of offline students. Doing your homework will not benefit anyone else other than you only, isn't it? If you do your homework, who will it benefit? You or me or you? It will benefit you only, right? Yeah, surely. If you have any doubts, see, I give the homework so that you can practice on your own. Okay, and then if you feel like you couldn't do any question or you had any doubt regarding any question, then you can ask me in the doubt session from the homework portion. Okay? Okay. Let us begin now. Let us start the next chapter. Our next chapter is chapter number 6. Chapter 5, LCM and HCF of numbers is over. Now it is chapter number 6. And yesterday I gave homework and none of the students here did them. Only Datta showed he tried 3 or 4. Just 6 of them. How many did you try? All of them. The only student who did all of them. What about others? Anyone else? No. He's sitting nicely at the back. What's your name? Preksha. And Preksha did all of them. Did you get all the answers correct?
Yes.
Match? Do you have any doubts? Okay. Madinath? What happened? All okay? Settled? So let us begin chapter number 6. Here, chapter number 6. Chapter number 6 is what? Decimals, isn't it? It's about decimal and fundamental operations on them.
Page number 42.
Chapter 6, we have just started. This is decimals and fundamental operations on them. So let us see. Chapter 6, your page number 43. So first, what is a decimal number? Who can tell me what is a decimal number? Let us see. We have done fractions before?
Yes.
We have done fractions before. Now, what are decimal numbers? Decimal numbers are actually related to fractions. Decimal numbers are actually Decimal numbers are actually related to fractions, isn't it? In what way? Let us see. Before that, let us see what is a decimal number. A decimal number will be a number which will look something like, let us see, we know what is 1, 2, we know the usual counting numbers, isn't it? First of all, we know these usual counting numbers. 1, 2, 3, 4, 5, 6, all these numbers we know. We know all the counting numbers which are also called natural numbers, 1, 2, 3, 4 and so on. We also know that if we include 0, it is whole numbers. And we also know that if we go to the negative side, -1, -2, -3, and so on. All these together form the set of integers. All this together form the set of integers. Now you are seeing that these are numbers, say 1 here, 2 here, isn't it? Now it may so happen that there may be a number between 1 and 2. There may be a number between your 1 and 2. Those numbers are called decimal numbers. Those will look something like, say, 1.2 or maybe 1.005. How do they look like? They look like something like this. It will have two parts. One part is this. This is called your whole number part. This is called the whole number part. This is called the whole number part. And this part is called the decimal part. This part is called the decimal part, isn't it? And these two parts are always separated by this point in between. You're seeing this point, this dot in between? So these two numbers are always separated by this point, this dot in between. And this dot, this point, we call it our decimal point. We call it our, let me write first, then I'll give you the side. Who is saying side, sir? Let me write first, Badrinath, then I'll give you the side. Where is Digant today? Digant didn't come. He doesn't write properly. Online class. So this point that separates our two parts, whole number part and decimal part, is actually called the decimal point. Okay? Now you can write. I'm on the side. Okay, Badrinath. First let me write what you're trying to copy, isn't it? If I don't write, what will you copy? You copy the blackboard, you copy the blank board. No, right? So, what does a decimal number look like? It looks like something a number which will lie between two of your whole numbers or two of your integers or between any two of your regular usual numbers that you have studied till now. Between any two usual regular numbers that you have studied till now or usual integers, isn't it?
Yes, sir.
Isn't it?
Yes, sir.
What is your name? Sahabi. Everything okay with your fingers? Okay. No issue? Is it paining? Okay. So, Sahabi, what is the decimal number? How many parts does the decimal number have? How many parts does the decimal number have? Huh? 3 parts. Decimal number has 3 parts. Sahabi, decimal number is there on your hand, on your fingers, or on the board. You can just simply look at the board, right? You can see the board, or you have to come here. Okay. So, what does the decimal number look like? It has 2 parts. And any number that will lie between any of our integers, any of our usual integers that we have studied till now, that will be your decimal number. A decimal number has 2 parts. One is the whole number part, another is the decimal part. These two. The 2 parts are separated by a point in between. That point is called your decimal point. That point is called what point?
Decimal point.
Decimal point. So the part written on the right hand side of the decimal point is called your decimal point. The part written on the left hand side is called whole part. Isn't it? This is our decimal number. Can I erase the board? Who said no, sir? Quickly write it down.
Sir, finish this.
Now, what do you mean by decimal places? What do you mean by decimal places? Page number 40. What do you mean by decimal? Number of decimal places. So what do we mean by decimal places? Let us see any decimal number, say 9.23. Now, in this decimal number, which is the decimal part? This is the decimal part, isn't it? This is our decimal part. Now, in our decimal part, how many digits are there? Two digits are there, isn't it? In our decimal part, how many digits are there? 2 digits are there. So, number of decimal places is how much? 2. I am not talking about your. No, I am not talking about your advanced 100,000. Here I am asking, what do we mean by decimal places? Okay. What do we mean by decimal places? So, what is the meaning of decimal places? What is the meaning? Jivan. What do you mean by decimal places? Okay. What do you mean by number of decimal places? What do you mean by number of decimal places? Your number of decimal places is actually the number of digits. Number of decimal places is actually the number of digits in your decimal part. Okay? Number of digits in your decimal part. The number of digits in the decimal part is your number of decimal places in that number. How many digits are there in this decimal part?
2.
So the number of decimal places? 2. If your number looks something like this also, 29.23. What is the number of digits in the decimal part? 2 only. In the decimal part there are 2 digits. So, what is the number of decimal places in this number 29.23? 2. Right. So that is the meaning of number of decimal places, the number of digits that will lie in the decimal part. Okay. Now let us look at. All okay? All okay? Yes, sir. Come on, just come on, quickly come on. Come on, come on, please. You can't see. Why? Hi. Okay, very good. Come in. So, this is your number of decimal places. Next, let us see what do we mean by decimal fraction. As I said earlier, decimal numbers and fractions have a very nice close relation, isn't it?
Yes, sir.
So now let us see what do we mean by decimal fraction. So, decimal fraction. Your decimal fraction is, if we know what are fractions?
Yes, sir.
Which can be written in the form P by Q. And this Q cannot be 0. Basically, fraction means a rational number only, isn't it? Now, in our decimal fraction, If a, what is a decimal fraction? If in a fraction, the denominator, what? The denominator here is 10 or it is a power of 10. Means it is either 10 or power of 10. Power of 10 means say 100. 10 or power of 10. Power of 10 means say 100. 10, 100 or 1000. Or it can be 10,000 and so on. Or it can be 10,000 or it can be 1 lakh, anything, something like this, etc. So if in your denominator it is 10 or a power of 10, 10, 100, 1000, 10,000, 1 lakh, okay, then such type of fractions are called decimal fractions. Let us say it is 3 by 10, it is 14 by 100, it is 2 by 1000, it is 12 by 10,000, 25 by 1 lakh and so on. Okay? These are what? Decimal fraction. Now we'll see how to convert this to
Decimal.
just a second. Before that, these are called decimal fractions. Now let us see the table for decimal place value. Just now Jivan was talking about place values, hundreds, thousands and all that. Now we'll see decimal place values. So these are your decimal fractions. Can I erase the board? Calm down, calm down. Done? Who said no? So now, let us see the table for decimal place value, isn't it? Now decimal numbers, we write them something like whole number part, point, then decimal number part, isn't it? They look something like, say 13.926. The decimal parts are this way.
The whole number parts are this side.
And the whole number part are this way, left side. So in place value, if we write ones here, what is this? Ones. Then we have tens here, isn't it?
Yes, sir.
Tens is on the left hand side of 1, tens. Right? Then after 10, 100. This will look 100 like this.
1000.
Yes, then 1000. Who said 200? Who said 200?
Dheeraj. Left.
I asked you. I was asking there. You were sitting there. Likit? It's fun for you, isn't it? It's fun for you. Huh? So after 100 we'll have 1000. Right? Then 10,000 and so on. This side there will be more. And this side, etc. Now this side also, after ones, this side is called tenth. Tenth means it will be 1 by 10. It will be 1 by 10. Or you can also write it as 0.1. This is 1 by 10, or you can say this is equal to 0.1. Okay. Then you have 100.
1 by 100.
100 means 1 by 100. This is your place value. Place value is 1 by 100, that is 0.01. 0.01. Then you have 1000 as well, and so on.
It can be more than this.
It can be more than that also, etc. Like there is 10. In normal place value, we have ones, tens, hundreds, thousands, then 10,000, lakh, 10 lakh, and so on. Here also it can be more than that. After 1000 also it can be 10,000. Then it can be 1 lakh, 10 lakh, and so on. It can go. It can go on and on. What happened?
Sir, you have to add TH.
TH, 1000. Yeah, you have to add TH in the name. You have to add TH in the name. Okay? 0.001. And so on, etc. So this is your place value of decimal numbers.
Don't run. Sir, don't run. Sir, don't run.
I'm not rubbing. Yes, Omkar, why did you raise your hand? Yes, Omkar, why did you raise your hand? Omkar, what happened? You are not able to?
Yes.
Sorry, Omkar, I can't hear you. What are you saying? You are not able to see the presentation. Omkar, what happened? You are not able to see the screen. Maybe there is a network connection on your side. You close your video, you switch off your video and try to see the screen. Try to open it, try to join again, okay? So this is your place value for decimal numbers.
Sir, the point is the ones, sir. In decimal, point is the ones, sir.
Here, for example, the place value for this. Here, for example, the place value for this 3 is ones. The place value for this 1 is tens. The place value for this 9 is tenth. For this 2 is 100. And for this 6 is 1000. Okay?
Sir.
This is your place value.
No, sir, for one, sir, in a decimal part, it is, sir.
There is nothing called ones in decimal point. There is nothing called ones in decimal point. Because 1 always means a whole, isn't it? In fraction, when I discussed fraction, I gave the example of a pizza, isn't it? I gave the example of a pizza.
Sir.
Huh?
Sir.
Did you bring a copy? Where is it? Why is it closed? Why is it closed? Simply. Where is the pen? Why is it inside the pencil box? You don't want to write, you don't feel like writing? Tired? Too tired? Is it paining? Then? What happened? What is the name? Bindu, na? Yes.
Sir, can you say?
So, these are place value for decimal numbers. Clear? After a decimal point, the first digit will occupy the place value called 10. The second digit will occupy 100. The third digit's place value is called 1000, and so on. 10,000, lakh, and so on. Next, we have operations on decimal numbers. Operations on decimal numbers. What are the operations? Usual operations: addition, subtraction, multiplication, and division. Let us see. Quickly note it down. Quickly note it down. Done?
Yes, sir.
Now we'll see addition of decimal numbers. How to do addition?
Yes, sir.
Suppose you have two decimal numbers, 6.54 plus 21.3. How to add these two decimal numbers? It will be 6.54 plus 21. We'll write this point here.
Yes, sir.
Below 6 we'll write 1, then 2. And here 21.3.
0.
This 3 will come below this 5. Okay.
3 after 0.
Then this 3 will come below this 5. So we'll write it like this, 21.3. This 3 will So now, let us see how to add these decimal numbers. We'll write this 3. We'll write this 3 below 5. We'll write this 3 below our 5. Now, but here, if we look at the number of decimal places, the number of decimal places is not equal. Here we just talked about number of decimal places. Here the number of decimal places is 2. But here only 1. So we should always make the number of decimal places equal first. And how to make this equal? Let us see. We will add a 0 here after 3. We can always, on the decimal part, after the decimal point, we can always add 0. We can add as many zeros as we want. We can add as many zeros as we want to make the decimal part, decimal number. We can always add as many zeros as we want to make the number of decimal places equal. We can always add as many zeros as we want to make the number of decimal places equal. For example, if here it was 6.549, then we could have added another 0 here. We can add as many zeros as we want to make the decimal places equal. In the decimal part, it does not matter how many zeros you add. It's the same thing. Okay. So now let us see how to add this. It will be like this. Now simply add them. 9 plus 0, 9. 4 plus 0, 4. 5 plus 3, 8. 6 plus 1, 7, and then 2. So the answer should be 27.849. Clear how to add two decimal numbers? This is how we add two decimal numbers. Clear, Hema? Very simple, isn't it?
Yes, sir. Yes, sir. Like normal addition. Yes, sir.
What are you doing? Want to disturb someone? Can I erase the board? Okay. Similarly, our subtraction is also in the same way. Our decimal subtraction is in the same way. And addition will be, before that, before subtraction, let us look at another addition. Say 21.3 plus, we are taking three numbers now. Say 160.05 and 29.627. So we have to now add three decimal numbers together. It will be the same thing like regular addition, but before adding them, we have to remember to make the number of decimal places equal in each number. You have to make the number of decimal places equal in each number. Your question is 21.3 plus 160.05 plus 29.627. Now in each of them we should make the decimal places, number of decimal places equal. Like this, yes. Now see, all of them have the same number of decimal places by adding zeros. Then you add them 700. You will add all of them like this, isn't it?
210.910.
We will add all these decimal numbers like this, right? So it will be 7 here, 7 here, 9 here, 0 carry 1. So it will be 210.977. That will be your answer. The answer is
210.977.
Don't call it 977.
977.
One important thing I want to tell you all, after the decimal point, whatever digits you may have in the decimal part, you will call the digits out individually. You will not say it is 977. No, you will say it is 210. But 210.977.
977.
977.
Sir, I got as 977.
Okay, so this is all about your decimal addition. Now let us look at Hema, increase your writing speed.
Okay, sir.
Dheeraj, have you done? Next, let us look at subtraction. Okay, subtraction of decimal numbers. Again, for example, you have 32.06 minus 20.153. Now, if I ask you to find the subtraction here, this is what? Subtraction, isn't it? If I ask you to find the answer here, how will you find it? Let us see. We will now again write them like this. 32.06 minus 20.153. Again we can see that here that number of decimal places is not equal. Here again we can see that number of decimal places is not equal. Here again we will add a 0. Here again we will add a 0 here, so that in both of them the number of decimal places become equal. Then we will subtract. 10 minus 7. How will you subtract here? You will subtract like this.
Yes, sir. 42.213 answer.
We are doing subtraction, not addition.
11.9.
Calm down. Yes, wait. You will do them like this. You will do them like this. See now. You will do the subtraction like this. Huh?
Sir, I didn't have textbook.
You don't have textbook. Why? You did not bring? Why?
Sir, I didn't go.
You didn't get textbook. Ask them about it. You didn't have textbook.
Sir,
I'm doing it. Calm down, calm down. What? You got the textbook? Madina? Satta? So, we'll subtract digit by digit. First, 0 is less than 3, so 0 is less than 3, so it will take 1 from the other side, it will become 10 minus 3, 7. Here it will be 5 minus 5, 0. Then, again 10 minus 1, 9. Point. 10 minus 1, 9. Put this point here. Then 1 minus 0, 1. And then another 1. So this is your final answer. 11.907. 11.907.
Yes, sir. No, sir.
So is it clear? Subtraction of decimal numbers?
Yes, sir.
Yes, Amulya, why did you raise your hand? Amulya, why did you raise your hand? This is your book. Yes, Amulya? Online doubt session from 7:30 to 8 o'clock, half an hour. Okay? Yeah. Yes, only for online students, 7:30 to 8 o'clock. Yes, Aishwarya, what is your doubt? Why did you raise your hand? Yeah, Aishwarya, why did you raise your hand? Oh, okay, you have a doubt. Okay, we'll do that after 7:30, okay? Okay. So, this is how we do subtraction of decimal numbers. Next. Next, let us look at multiplication of decimal numbers.
Yes, sir.
Very carefully look at multiplication of decimal numbers without talking. Very carefully. Multiplication. Now, multiplication, Hema, all okay? Now multiplication, you are not able to see from there. Multiplication of decimal numbers. Say we have two decimal numbers, 2.34 into 6.1. They've asked you multiply these two and find the result. Okay. Now 2.34 into 6.1. These are two decimal numbers and you have to multiply.
Yes, sir.
Here, you don't need to think about number of decimal places being equal or what. We don't need to see that. How will we multiply? Let us see. First, we'll write these two decimal numbers without the decimal point. We'll write them like whole numbers. See, I'm writing the two decimal numbers without the decimal point. Without decimal point, it will look like 234 and 61, isn't it?
Yes, sir.
I'll write it like that. Then I'll multiply these two numbers. Don't write the decimal point first. Simply write the numbers without the decimal point like this. Okay? Now multiply them 234 into 61.
Yes,
Okay?
So we got answer. Sir, 742.5.
It will look something like this.
Yes, sir. 7, 2, 4, 1.
14274, isn't it?
14274.
14274. So now this answer is okay. So now we multiplied the two decimal numbers without a decimal point to simply like whole numbers and we got this, isn't it? We got this. Now, what will be our final answer? Let us see. In a final answer, we'll write this. We'll write this. How will we write this? Let us see. We'll write this as 14274. We're writing it like this. But now it is decimal numbers, right? It's not just whole numbers, it's decimal numbers. We will see how many decimal places are here.
2.
Number of decimal places 2. And here number of decimal places 1. So 2 plus 1. So 2 plus 1 will get 3. So here number of decimal places in the first number is 2. In the second number it is 1. Together add them, total number of decimal places should be 3. Total number of decimal places should be 3 in the final result. And how they should be 3?
After 3 numbers.
There should be 3 like this, isn't it?
Yes, sir.
From the right hand side, 3 digits. From the right hand side, 3 digits. So see, in this final now, how many decimal places can you see? 3. So your final answer is 14. So your final answer is 14.274. It's 14.274. Easy, understood how to do multiplication?
Yes, sir.
Okay. Quickly note it down,
Sir, division. Sir, next division. Point we should put point. Yes, sir. Sir, there is. Sir,
Is it over?
Sir.
Okay. Now everyone write a question for homework.
Yes, sir.
Your homework question is 20.91 into 3.5 equal to dash. Next question, 32.7 into 60.9 equal to dash. These two questions try for homework
Yes, sir.
till now.
Yes, sir.
Try these two questions for homework. Okay? These are your two questions. Try these questions at home. Okay?
Yes, sir.
Okay? Done? Written?
Yes, sir. Yes, sir.
Question A? What happened? Did you write it down? And why are you turning back? Now let us see multiplication now. If you have a decimal number say 132.675. Now what will happen if I multiply this number by 10? Very interesting. Now we'll see what will happen if we multiply this number by 10 or its higher powers. Okay? We'll multiply the same number like this. Here, we don't need to do too much work. Here, we don't need to do too much work. Here, we don't need to do too much work. If you have any decimal number,
Yes, sir.
if you have any decimal number to be multiplied with 10 or its higher powers, 10, 100, 1000, 10,000 and so on, then I'll show you another thing. This one also. Into 1, 0, 0, 0 and 0. If you have something like this, then what will happen? Then we can simply write the answer directly. How? Let us say, if it is 10, in 10 there is only 1 0. In 10 there is only 1 0. So this decimal point you can just shift it one place to the right. And the final answer will be 1326.75. This shortcut method you can use. This shortcut method you can use when you have a decimal number multiplied by 10 or its higher power. 10 or its higher power. 10 has 1 0, so one place to the right, it will become like this. 100 has 2 zeros, so decimal place will go 2 places to the right. It will become 1326.7.5. Next, 1000 has 3 zeros, so it will go 3 places to the right. It will simply become 1326.75. That's it. The point is coming here. You can just let me speak. You can just keep it up to 5 like this, or if you want after the point, as I said, you can write 0. As many zeros as you want, isn't it? You can either write as many zeros as you want, or you can just keep it up to this. It becomes your this number. Now, very interestingly, let us see this. There are 4 zeros here, isn't it?
Yes, sir.
Now you have to shift this decimal place 4 places to the right. But you don't have 4 decimal places. So what to do? I can add an extra 0 here.
Yes, sir. Yes, sir.
I can add an extra 0 here.
Yes, sir.
And it will shift right after this 0.
Yes, sir.
And it will become 1326.750. Then this will become only up to this.
Yes, sir.
Okay?
Yes, sir.
This is a multiplication by 10 or higher powers of 10, isn't it?
Yes, sir.
Here.
Yes, sir.
Quickly note it down. Quickly note it down. Calm down. Keep quiet and quickly note it down. What happened? You're dancing? Dancing.
No, sir, I'm not done.
Don't review on how to done. I told you to do it home. You do yesterday's homework? No. So what is this homework session? Like I'll do the homework now and show stuff. Show it to me tomorrow. Quickly note it down. You note this down. Do you understand this?
Sir.
Okay. You did this? Now go home, check with the calculator is correct.
Sir, sir.
You check with calculator. Is it clear how to multiply by 10 or higher powers?
Yes, sir.
10, 100, 1000, number of zeros.
Yes, sir.
The number of zeros you have, just shift them to the right.
Yes, sir.
Okay? Shift that many decimal places to the right, as many number of zeros you have.
Yes, sir. Finish, sir. Finish, sir.
Okay. Now next, let us see division by division of decimal numbers. Division. So, division. Let us see. If you have a question like this, 2150.76 divided by 76, this is too big. Let's say you have the question is 50.762 divided by 0.25. Okay? Divided by 0.25. Then how to do the division? First, we will remove the decimal point from our divisor. Here the divisor is 0.25, isn't it? First to remove the decimal point from 0.25. How to remove it? Let us see. We have 50.762 divided by 0.25. How many decimal places are there in 0.25? Two decimal places. So we'll multiply both of them by 100. Two zeros. Two decimal places, so two zeros. Okay? Two decimal place, so two zeros. If you multiply by 100, the decimal place will shift two places to the right. This divisor will become 25 and the numerator will become, your dividend will become 5076.2. Isn't it? It will become 5076.2 divided by 25.
So second of 25.
So now you just have to do what? You just have to do, you just have to divide 5076.2 by 25. Okay? Question? What you have to do when you have division of decimal numbers? You have to first remove the decimal point from the divisor. Here our divisor is 0.25. Here our divisor is 0.25. Since you have two decimal places in the divisor, so we'll multiply both our dividend and divisor by 100. We just did powers of 10 multiplication. If you divide by 100, there are two zeros. So two decimal places will be removed from the divisor, it will become 25. And the dividend will become 5076.2. Okay? Now you have to divide 5076.2 by 25. Usually do the usual division, 25 into 2, 50. Isn't it? Next, 7 will come down. Right? So we'll put a 0 and bring down 6 because 7 cannot be divided, isn't it?
Yes, sir.
76. 25 into 3?
75.
75. Very good. Remaining 1 is the remainder. But now, but now, huh?
Sir, we have to take the point. We have to take the point and place next to it.
Now, after we get this remainder 1, now we have to bring down this 2, isn't it?
Yes, sir.
But now, immediately as we go on to this 2, we are actually crossing this decimal point, isn't it?
Yes, sir.
We are going across the decimal point and bringing this 2 down. So we'll put a decimal point on the quotient as well. Okay? We'll put a decimal point on the quotient as well. So we'll put a decimal point on the quotient also. Here, when we are bringing the 2 down, just now, we just crossed this decimal point. So we'll put a decimal point in the quotient also. Okay. Now we have 12, isn't it? Now we have 12. You have to divide 12 by 25. Can you do it? No. So 25 into 0, isn't it? We'll put a 0 there and another 0 here. Now 25, 120. We can do something. 25 into 4. 100.
Is equal to 20.
So now remainder is how much? 20, isn't it? Remainder is 20.
Yes, sir.
Now, hold on. Wait a second. Just a second. I'll put it here. Now let us see. Now, after 25 into 4, we get 100. Our remainder is 20, right? Now we are still not getting any remainder is 0. We can still divide. How can you divide? Let us see. Since we have already crossed our decimal point, isn't it? Since we have already crossed our decimal point, now we can write a 0 here in place of near 20. We can write 1 0 near 20. Every time we divide. Okay? How can we write 0? Because there is a 0 after this 2. We can write as many zeros as we want, isn't it? We can write as many zeros as we want. So this 0 came here and this 0 is coming from another 0 here. Okay? So after we cross at the decimal point, remember it, G1, the board is at the front. It is not in.
We can write how much we want. We can write
As many zeros as we want until we get our remainder 0. Until we divide it completely, we can write as many zeros as we want. So after we cross, remember it very carefully, after we cross the decimal point, now we can write 1 0. Here we can write only 1 0. Okay? Here we can write only 1 0. Here we can write only 1 0. If you see that the remainder is not, there is still a remainder left. If you see that there is still a remainder left, we can write exactly 1 0. Exactly 1 0. Okay? That is why near 20 I wrote this 0. Okay? Don't write a 0 in the quotient. Don't write a 0 in the quotient until unless you have to bring down another 0. We can write only 1 0. Now if we need another 0, say this was not divisible by 25, say, then we have to bring down another 0. At that time, we will write 0 in the quotient. So at a time, always remember, at a time only 1 0. At a time only 1 0. Very carefully remember it. At a time here, I can write only 1 0 after I cross decimal point. Okay. At a time only 1 0 after crossing the decimal point. Remember it.
So we can divide it.
So now, after we wrote this 1 0, we have got 200, isn't it? The initial remainder was 20 and now we have got 200. With this extra 0, we have got 200. So now we can easily divide.
25.
We can divide 200 by 25. And dividing 200 by 25 will give us 25 into 8 here. Will be 200. And finally we get a remainder 0. So our answer here, after dividing this, our answer is this. Yes. Yes. So 50.762 divided by 0.25 is equal to the quotient 203.04. Okay. 200.04. Is it clear? Division.
Yes, sir.
After, remember this very well. After crossing the decimal point, you can write only 1 0. If you have to write another 0, then you have to add a 0 in the quotient.
Yes, sir.
But normally you can write 1 0.
Sir, after decimal point we can put how much 0 we can put.
Where?
After decimal point in the quotient.
Quotient not here.
Quotient.
Quotient. Where?
Sir, after decimal point in quotient, we can write how much 0 we can put.
Why are you writing in the quotient? Quotient
Sir,
is this
to
quotient.
get answer.
To get?
Answer. Sir, he is telling me.
Quotient, no. Say dividend. You are talking about this portion, na?
No, sir, quotient only.
Quotient. Quotient, why do you need to write 0? Where did you have to write 0? What did I tell you? After you cross the decimal point, after you just touch the decimal point and then bring down the number after the decimal point, we got down 2. We have put a decimal point in the quotient as well. After 203 in the quotient here.
Sir,
Right.
We should not put a 0.
Now after bringing this 2 down, we saw that 12 was not divisible by 25. 12 was not divisible by 25. That is why we wrote this 0 in the quotient. That is why we wrote that 0 in the quotient. Okay. We saw that 12 was not divisible by 25. That is why we wrote that 0 in the quotient. And we wrote as 0 here.
Sir, we took 0 and 20 now, sir. Why could we not write 0? Sir, we took 0 and 20 now, sir.
Yeah.
Why should we not write 0 in the quotient?
What did I say just now?
Sir,
After crossing the decimal point,
sir, we can
after crossing the decimal point, see.
Saturday and Monday.
After coming here, the remainder is 1. Now we are crossing the decimal point and bringing down this 2. So I'll put a decimal point in the quotient. We have already brought down a number 2. Now can you divide 12 by 25? In division, after getting a remainder, we bring down one number, isn't it? We brought down one number 2. Can you divide 12 by 25?
No, sir.
No. So we need
0.
another number to bring. I need to bring down another number. We need to bring down another number from the dividend, isn't it? And to do that, in division, we always add a 0 in the quotient. To bring down a number from the dividend, we add a 0 in the quotient. So we bring down this 0 and we added 0 in the quotient. Okay. Next we can divide 120 by 25. 25 fours are 100.
100.
Now the remainder is 20. The remainder is 20. So now we have to bring down the next number, which is 0 again. Because there is no other number, we can write as many zeros as we want here. So we brought down this 0 again. It will become 200. Now, just this 0, one number. Now if this was not divisible by 25, we would have brought down another 0 and written a 0 in the quotient. But we are bringing down only one number. In division, the normal division only. In the normal division only, if you bring down one number and it is divisible, you don't need to write 0 in quotient. But in normal division only, if you bring down one number and it is divisible, then that is it. 25 and 200. 25 8s are, isn't it? So 25 8s are 200.
0.
Remainder is 0. You don't need to do any more division. Clear? The quotient here is 203.04. Okay. Okay? Everyone understood how to do division of fraction, division of decimal numbers?
Yes, sir.
Okay. Okay. So, everyone sitting here, who has a doubt? You have a doubt? You study? You study? You have a doubt? You have a doubt? What is your doubt? I gave you homework. Did you even try them? You didn't try them. And you have a doubt. When do students have a doubt? After trying something, if you can't do, then you have a doubt. What doubt do you have? Huh? You try to do this question. You try to do this question. Huh? You try it at home. You try it at home. Then first try it today. Then if you can't do, ask me. Who else? Which one? We'll do it. We'll convert that. That is conversion. Tomorrow will be. Where are you going to be? You want to go home? You want to go home? You can go. If you want to go home, you can go. Tomorrow I'll meet your father. Okay? We'll do this tomorrow. Huh? So for homework, isn't it? You try to do this. And what doubt you are asking for? You try the fourth one. First go home, put it, try, then if you can't, ask it. What do you mean by doubts? My first question is, what do you mean by doubts? Something that you have not tried, or something that you have tried and couldn't do. Doubt means something that you have tried and couldn't do. Or doubt means something that I explained and you didn't understand. Doubt means something that I explained and you couldn't understand, or something that you tried, some question and you couldn't do. Something that you have tried and couldn't do, that is your doubt, and something that I explained and you couldn't understand. Doubt doesn't mean that, sir, I did not try, so this is my doubt. That is not a doubt. That is, you are asking me to do that question now for you. First try the question, and then if you can't do it, we'll do it. This one we'll do it tomorrow. And today, since we have started decimal numbers, he is asking, sir, this one, sir, this one, sir. Doubt is not just for asking this one, sir, Today we just started the 6th chapter, and you are asking doubt from chapter 6. Do you try that question? Try that question. Tomorrow we will do chapter 6. Tomorrow we will discuss. Today we discussed division of fractions. Doubt from the first chapter to division of fractions. Number 8. Did you try? When did you try? You said you tried from 1 to 6. You did not try it. You tried it at home. You tried it. And you couldn't understand it. Okay. They have not mentioned it. They have not mentioned the property. No. Wow. Okay. Now everyone sitting at home and sitting here. Everyone sitting at home and sitting here. Listen to one very important property about LCM and HCF of numbers. Very important property. Very important property. Okay, Sali. The property is not in Hema's face. If you have two numbers, any two numbers, any two numbers, okay? For any two numbers, remember it, only two numbers. For any two numbers, remember this, HCF of the two numbers into LCM of the two numbers is equal to product of them, isn't it? Is equal to product of the numbers. Okay? HCF into LCM is equal to product of the numbers. Remember this. Okay? That's all. Now try it at home. Remember this very important property about HCF and LCM. HCF and LCM of two numbers, not more than two. Exactly two numbers. HCF into LCM equal to product of the numbers. HCF into LCM equal to number into number. Okay. You try it at home. That you asked it, no?
Yesterday I asked you.
What did I say?
Tomorrow I will do solution.
Common the question. Oh, wrong. Common multiple of number 7 and 17 within 5 multiples. Number 13. 13. What happened to the
The common multiple.
13, 13, 13,
What is this multiple?
this is printing mistake. So question number 13 is completely wrong. Printed wrong. Don't worry about it.
They asked us 15 multiple. It's wrong. But there are so many
Putting mistake is there. And now, here is the method. There are 8 here. What is this question? What is this method? This is the division method for LCM, not HCM. So I did not tell you to try now. Try it at home. This is your Devas HCM. You did LCM division. You did LCM division. Okay? Any more doubt here? Question number 13. Question is wrong. Question is wrong. Question is
Sir, once you do the correct answer, do the correct answer.
question number. Okay. Anyone has any other doubt? No. Okay. I'll just quickly tell one thing. What is this? Chapter 4? Page number?
Sir, 72, 32.
13, huh? Chapter 4, page number 32, question number 13. Everyone sitting at home and in the class, listen very carefully. Look at your books. Look at your books. This question is printed very wrong. This question is printed very wrong. There is printing mistake in the question. The question could have been common multiple. Common multiple of 7 and 7.
So 17.
No, the question should have been common multiple of. The question should have been simply. The question should have been simply multiple of 7 and 7 within 5. The question should have been simply multiple of 7 and 7 within 5.
5 multiple.
Within 5 multiple. Okay? Within 5 multiple. The question should have been multiple of 7 and 7 within 5 multiple. Within 5 means it should be less than 7 into 5. It should be less than 7 into 5
35.
for both of them.
Less than
35. 7 into 5, 35. Okay. In option number A, listen very carefully. In option number A, you have it should be 7 and 7. In option number A, you have option number A has 14 and 42. 42 is not less than 35, isn't it? Both numbers should be 7 and 7 within 5 multiple. We should be less than 35. Something comma something, both should be less than 35. In the first option it is 42, so it is wrong. In the second option you have 14 comma 30, isn't it? 14 comma 30. This 30 is not a multiple of 7. Is 30 a multiple of 7? 30 is not a multiple of 7, so this option is also wrong. Option number C, 14 comma 28. Both of them are less than 35. Both are multiples of 7.
Yes, sir.
So this option is correct.
7 to the 14, sir. 7 to the 14.
7 to the 40.
7
to the 14 and 7 4s are 28. And the final one is 21 and 56. Both are multiples of 7, but 56 is not less than 35. It is greater than 35, so it is also wrong. That is why option number C. Okay? Okay. There is printing mistake in the question, that is it. That will be all of my students. Go home. What? What? What happened? But now we will begin our doubt session with the online students. Huh?
Sir, for only 2 questions.
Okay. Now let us see. We are in the doubt session. Madhu, what is your doubt? Madhu, why did you raise your hand? Madhu, do you have a doubt? You have a doubt from? Decimal of fraction, chapter 6. What doubt do you have? Tell me, Madhu. Okay, what is your doubt? Tell me. What is the doubt? You did not understand. That is, decimal fraction is actually regarding your place value, isn't it? See, we did that place value, right? Here, we know ones, Madhu, ones, tens, okay? Then you have hundreds, thousands and so on. So in decimal part also, you will have tenth. Tenth means 1 by 10, okay? Then you will have hundredth. Then you will have hundredth. Hundredth means 1 by 100. Okay? Then you will have thousand. Then you will have thousand, which is 1 by 1000. And so on. It can go more and more, okay? So these are your place values. These are basically your place values. And how do we write them? See, if you have a number, say 13.256, okay? Here the place value for 3 is ones, okay? For 1 it is tenths, the whole number part. Now for this 2 in the decimal part, it will be 1/10. For this 5, it will be 100. And for this 6, it will be 1000. Okay? And say this 5 is here now. This 5, what is the decimal place for this 5? 100th, isn't it? So its face value is 5, but what is its place value? Its place value is 5 into 1 by 100, okay? Do you remember place value, face value from the first chapter? So place value is 5 into 1 by 100. Place value for this 1 is what? 1 into 10? Isn't it? Similarly, place value for this 5 will be 5 into 1 by 100. Okay, Madhu? This is actually 5 by 100, which is equal to 0.05. Okay? Why 0.05? Here there are 2 zeros, isn't it? Here there are 2 zeros. You are dividing 5 by 100, right? Here there are 2 zeros. So you have to write the decimal point 2 places on the left of 5. Okay? So 2 decimal point, 2 decimal places. Clear? 2 zeros, 2 decimal places. Is it clear now, Madhu? Okay. Yeah, welcome. Next. Is it Aishwarya? Is it Aishwarya? Yeah, what doubt do you have? Tell me. HCF, yeah, tell me. HCF what method? Division method to find the HCF of more than 2 numbers. Yes, you can do that. You can do that. Aishwarya, you can use division method to find the HCF of more than 2 numbers. Okay. Let us see. Let us see 16, 24 and say 32. Okay. You have to find the HCF. Isn't it? So now, in division method, we actually take 2 numbers at a time, isn't it? In HCF, for HCF of 2 numbers, we take two numbers at a time. So in division method, first if you take 16 and 24, do the division method, what will be the HCF? Eight. The answer will be 8, isn't it? Yeah. So your HCF of 16 and 24 is 8. Now take this 8. Now see, now Aishwarya. Now take this 8 and find the HCF with 32, the last number. Understood? So I will now find the HCF of 8 and 32. Understood? Now you have to find HCF of 8 and 32. Clear? Yeah, 8 4s are 32. So what is your final HCF? The last divisor, 8 itself. Understood? 8 is the final answer of HCF of 16, 24 and 32. So understood, Aishwarya? First take HCF of 2 numbers, then their HCF, this 8, you have to take the HCF with 32, the last number. If there is some other number, again take this 8 with that other number. Understood? Okay. Yeah. Hi Udit, what is your doubt? You raised your hand. Udit? Hello, what is your name by the way? Udit, na? Okay, Udit, what doubt do you have? Entrance corner of which chapter? 5. Okay. Lesson number 5, entrance corner. Which question? Question number? Okay. First and fourth. Let us look at question number 1. Question number 1, na? Okay. So let us look at question number 1. What is question number 1 given? The number of numbers which are the multiples of both 3 and 5. Udit? Yeah. This is the question, right? The number of numbers which are the multiples of both 3 and 5 in the first 100 natural numbers, right? Okay. Now see, Udit, number of numbers which are multiples of both 3 and 5. Now see, we are talking about multiples of 3 and 5, isn't it? So what is the first multiple of 3 and 5? The very first multiple, it will be the lowest common multiple, isn't it? It will be the least common multiple or LCM, correct? So first find the LCM of 3 and 5. What is the LCM of 3 and 5? Do it and tell me. 15. So this is your first common multiple of 3 and 5. Understood? So this is the first common multiple of 3 and 5. Now, with the help of 15, you will find all the other multiples. All the other common multiples. All the other. And I told it, I think in the previous class also I told you. All the common multiples will be a multiple of your LCM, okay? All the common multiples are actually what? They are multiples of? Udit, they are multiples of? Udit, can you hear me? Yeah, all the common multiples are actually multiples of LCM. Okay? So, what are our multiples of LCM? 15 into 1, 15 into 2, understood? 15 into 3 and so on. Like this, you will find how many numbers, how many such multiples are there in the first 100 natural number, isn't it? See, Udit, after this, when you do 15 into 6, what is 15 into 6? 90. See, 15 into 5, 15 into 6 is 90, isn't it? But 15 into 7 is how much? 105. 15 into 7 is how much, see? 105. This is more than 100. So you cannot take this. So, how many multiples are you getting? How many common multiples of 3 and 5? Less in the first 100? 6. So your answer should be 6. Option number 4. Clear? Is it clear? Udit? Okay. Any other doubt? Fourth one means HCF of two numbers 38 and the LCM is given, na? That one, Udit, just now, did you see? We just discussed a property of HCF and LCM of two numbers. HCF into LCM equal to product of the numbers. So we'll use this, okay? Try to use this and solve it yourself. See, HCF into LCM equal to product of the numbers, okay? So now, Udit, HCF is given is 38, isn't it? Into what is the LCM? Exactly. 98,154. It is equal to product of the two numbers. Now one of the numbers is given 1558, isn't it? Into your second number, suppose I take it x. Suppose I take that second number as Udit x. Okay. Suppose that second number I am taking as x. Remember, we always take whenever we have some unknown number, okay, so any unknown quantity. If we have any time any unknown quantity, we always consider that as x. Okay? Yeah. We use x to consider any unknown quantity. Clear? So now, see Udit, what will be the value of x? We have to find this other number, isn't it? So what will be the value of x? Exactly, exactly. This will come as this side as division, isn't it? Understood how to do this? And now you can cancel and find the answer. You can do the division. Okay. Okay, Udit, that will be all, isn't it, for you? Okay. Next, Varshit, what is your doubt? Tell me. Varshit. Yes, Varshit, what is your doubt? Yeah. Tell me. Fourth question, chapter 5. Okay, chapter 5, self-practice, na? Okay. So, the fourth question, what is the question given? The least number such that when it divided by 15, 25, 35 and 45, it leaves remainder 7, 17, 27 and 37 respectively is. Isn't it? Varshit? Yeah. Just a second. So, yesterday last day we did some such type of questions, didn't we? Varshit? We did such type of questions last day, I think. Now here, Varshit, see the thing very nicely. You can do it very quickly, okay? Varshit, can you hear me? Yeah, Varshit, yeah. See here, this you can do it in two ways, okay? See very carefully. What are the divisors here? 15, 25, 35 and 45, isn't it? These are your divisors. And they will leave a remainder, they will leave some remainders, isn't it? They are your divisors. They will leave remainders. What are the remainders? 7, yeah, 7, 17, 27 and 37. Now, see very nicely, very carefully. So, after they leave these remainders, then you have to find the least number such that when it is divided by these numbers, it leaves remainder like this. Isn't it? Now, that number, whatever that number is, say it is x, okay? If it is x, then if I take x minus 7, x minus, then that will be exactly divisible by 15, yes or no? Varshit? From yesterday's class, do you remember? See, if I If I divide 11 by 3, what is the remainder? 2, isn't it? Dividing 11 by 3, remainder is 2. So see this, if I take 11 minus 2, if I take 11 minus 2, then this will give me 9. And this 9 is exactly divisible by 3. So same way, if I take x minus 7, it will be exactly divisible by 15. Understood? And the same number x minus 17 will be exactly divisible by 25. And the same number x minus 27 will be exactly divisible by 35. And the same number x minus 37 will be exactly divisible by 45. Clear? Understood? So now whatever these numbers are, whatever that number is, Varshit, how to find this number? See, how can I find this exactly same number? How can I use HCF and LCM to find this exactly same? Yeah, tell me. No, 20. No, you should. No, not like that. Varshit, I told you, you understood this? If you do minus minus, x minus 37 is divisible by 45, isn't it? Yes. So now this you can do it in two ways, okay? One way you can do is check all the options. You have 4 options. Check those options, put them in place of x. One by one, check them and check whether it happens or not. Okay? Check whether x minus 7 is exactly divisible by 15, x minus 17 exactly divisible by 25, x minus 27 by 35 and x minus 37 by 45. Okay? There is one way you can check by using your options. Isn't it, Varshit? Yes. And another way you can check is by taking LCM. By taking LCM, exactly. Now, hello, Varshit, can you hear me? Yeah. Now, just a second. So, see here, Varshit, what is the LCM of these divisors? Find the LCM of 15, 25, 35 and 45. What will be the LCM? By division method we can do. By 5 I can divide all of them. Then let me erase this portion. Then after this, you can divide them by 3. 5 and 7 will remain same. Then here only this 5 is coming. And here 7. Okay. And here only 3. Isn't it? So this is your LCM. Multiply them together and see what is the LCM. 5 into 3 into 5 into 7 into 3. What is this? Check it. It will be 1575, okay? It will be 1575. But, Varshit, this is the LCM, okay? This is not our final answer. This is not our final answer. Understood? This is not our final answer. What should be our final answer? What should be our final answer? No, see, Varshit, see here, 11 minus, here we did 11 minus 2, 9 was divisible by 3, isn't it? But 11 plus 1 equal to 12 is also divisible by 3. So here see, your x minus 7 is divisible by 15, isn't it? Okay. Now, also you can see that x minus 37 will be divisible by 45, isn't it? So, x plus 8 will also be divisible by 45. And this x plus 8 which is divisible by 45, Varshit, can you hear me? Varshit, can you hear me? Can you hear me? So this, see this x plus 8 which will be divisible by 45, is it? Just a minute here, now you can see the board. So this x plus 8 will be divisible by 45, isn't it? So this number can be your LCM. Understood? So 15 plus 75 is actually x plus 8. So what is this x? This is 1575 minus 8, isn't it? Which will be 1567. Okay. That is your answer. Option number D. Option number 4. Is it clear, Varshit? Understood how to do this question? Okay. Yeah, you can leave the meeting, Varsha. I'll take one last doubt. Vagmi, what is your doubt? Who? Danvi? Decimal, you can't understand multiplication division. We did this today in the class, isn't it, Danvi? You couldn't understand anything? Where? In which one? Okay. Okay, Danvi, do one thing. Now it's getting a little late, so we'll do the doubt tomorrow, okay? Huh? And I hope you get your book, and you have any other book where you have decimal chapter? Okay, yeah, in that you have decimal, just go through that once, and tomorrow you'll ask me the doubt again, okay? Yeah, tell me, what is your doubt? Decimal division or which one? Division. Decimal division. Okay, this division we just discussed, isn't it? Okay, let us see. What is your name? What is your name? Manvita. So Manvita, decimal division. Decimal division, see, if you have to divide, say, a number 32.14 divided by, say, 2.5, okay? Now, your divisor is 2.5, isn't it? You have to remove the decimal point from it. How many decimal places are there? One decimal place. So I will multiply with 10, 10, okay? And I'll multiply that in the numerator also. And this will totally become what? The dividend will become 321.4 and the divisor will become 25, isn't it? Now we will divide 321.4 by 25. Okay? Now see, 25, 1, 25, do the division, 71. 25 2s are 50, isn't it? Remainder 21. Now, Manvit, now see, just a minute, see here. Here, we have now just crossed this decimal point and we have to bring down this 4, isn't it? So we'll also write a decimal point in the quotient. Okay? Now 25, how much 214? 25 into 8? 200? Remainder is 14, okay? Now we have to bring down another number because we still can divide. Now see, after the decimal point I can write a 0 in here in the dividend. And I'll bring down this 0. Okay? And now it will be 25 into 5, isn't it? 25 into 5, it will be 125. Right? 15. Now again I can bring down another 0. Okay? Manvit? So 25 into 6, 150. Now your remainder is 0 and this is the end of your division, isn't it? Understood, Manvit? So what is your final quotient? 32.14 divided by 2.5, your quotient is how much? Exactly, this is your answer. Clear? Okay, that will be all for today. Okay, everyone. Yeah, welcome. That will be all for today, everyone. This is the end of our meeting. We'll again meet tomorrow. Okay, this is the end of our class. Yeah, bye.